Can you hear me? Good morning. Bright and early. Friday morning. So we'll have class until 11:30 today because I need to step out. If that helps you in your planning. So this is where we left off, and hopefully you had a chance to watch the other video to see how to set up your calculator, that you have a finance calculator. And I did say I was going to show you Excel, right? I'm trying to think. Maybe I'll show you that at the end. I'll get through the formula and the different variable solutions, and then I will demonstrate how to get the answers in Excel as well. You should know this, right? You should know this from 3106. But we're reviewing, and then like I mentioned in the first class, we're going even deeper. All right, so I sound clear? As people are saying yes. My microphone's a little... There. I don't know about the TI Aspire. I'm sorry, Diego. If you know how to use the finance keys on there. Let me check. I'll just check online if that's finance keys. Oh, it's a finance solver. Okay. Yeah, if that's what you like, but that is not an acceptable calculator for the CFA exam. If you're interested in writing it, you'd have to learn the TI BA2 plus. Okay. So it's TI BA2 plus and HP 10B2 are the, I'm writing a note in the chat. Okay, the only calculators, I spelled that wrong, but allowed in writing the CFA exam. That's why I'm focusing on them. Now, some students ask for the notes on how to use the HP calculator and also the TI-84. If you want those notes, you have to inbox me. You have to email me, and I'll send them to you, right? I'm not going to send them to everybody and fill their inbox if they don't need it. All right, so let's pick up where we left off. So what did we say here? So I explained, okay, so we talked about the basic time value of money relationship. I explained where it comes from. We derived the formula together. 0 means now, T means the duration of a lump sum investment. So we accumulate with the accumulation factor for T periods to get to the future value. So this is for the principal amount, or the present value accumulates for T periods for a new future value. Now, writing out this formula is not going to get you points in this class, right? I explained last week, that you must present me the formula with the numbers included and the answer. Just showing me this is not going to get you anywhere. So we learned about the fact that if someone gives you 3 of the variables, you can find the 4th. And it's not just FV you can find. If you have the future value, then you can find one of the other variables. And that's what we're working on now. So I first begin with saying, let's find the present value in this formula. And I provided this example explaining what if we're talking instead about receiving $1,000 in 2 years. If we're to receive $1,000 in 2 years in an investment, So there's a financial opportunity and you're guaranteed $1,000 and you're told that the rate of return is 8%, then how much are you willing to pay for that? So we have now to discount this amount, this is called discounting, to determine what it's worth to us. So this is the minimum, this is the maximum anyone would be able to pay or prepared to pay. This is the fair price for $1,000. Now, if someone offered you this deal for less, you should go for it, right? Because it's a bargain. But this is the fair price. Questions? I also explained, what if the $1,000 is to be received? You don't have to invest in it right now. But what if it's to be received? I leave that open to interpretation here, right? I told a story that it was a financial opportunity or an investment opportunity. But in fact, what if you're getting a gift of $1,000 in 2 years? Does that have value today? Yes, it has the same value, but the interpretation is slightly different. The interpretation would be that because I know I'm getting $1,000 in 2 years, I could borrow against getting $1,000 in 2 years, and this is the amount that I could borrow. Why? Because this amount is going to accumulate interest, so that I have to pay $1,000. So the $1,000 debt in 2 years will be paid with the $1,000 gift. Questions about that interpretation? So the main difference, well, it's a different storyline, and the different storyline is going to tell you that in my second storyline, I would actually, in entering this into the calculator, the FV I could enter the FV, well, the FV is going to be a positive in the first story because I'm receiving that if I invest this amount today. That's why it's negative here, and so this is the answer I get. If I'm borrowing against it and I'm looking at paying this back, so I would put it in as a negative in the second storyline. I mean, no one's checking what you're putting in. I'm just helping you interpret how you rationalize the two approaches. So in the second scenario, FV is a negative because you have to pay it back because you're borrowing against it, and PV would be a positive. But no one's going to check what you put on your calculator. I'm just helping you understand the distinction of the two interpretations. Did we lose connectivity? Hold on. Are you guys seeing this? Hold on, I gotta refresh my screen. Remember, if it looks like blurry on the screen, refresh. Also, if it looks like I'm talking about something that's not appearing, then refresh your screen. That probably doesn't happen for you. It happens on my side. Okay. Now, what about the other variables? What about so this time I'm going to give you FV, PV, and T, and you have to find I. So I could just enter everything into the relationship, the time value money relationship. This is my timeline. Cash outflow of $900 turns into $1,000, so this is negative. Present value, positive, future value. And that's important. Can't forget about the signs, or you won't get an answer. You'll get an error on the calculator. So let's try this. If you went ahead, how many of you worked ahead already with the notes in your review? You can let me know in the chat. But hopefully it's not too boring or redundant. It's really important to establish this foundation. As I said, we're going to make it nice and complex. So let's enter 2 periods. Interest is what we want. Negative 900 is the present value because it's being invested. There are no payments in this problem, so the calculator is told 0. Just as you have to put a place mark here. And then a positive future value is what you will receive. So putting that into the calculator, computing for the interest rate, you get this amount. So what I'm going to do is do that now. Did I do this already? I feel like I did this already. So I enter 2. Oh, let's clear TVM second, clear TVM, and then 2. Interest is what I'm looking for. I leave that blank. PV is 900 invested, negative. Payment, I don't have a payment. It's a basic lump sum problem. And the future value I will receive 1,000. So compute I is my answer. That's it. Everyone got it? So there's several decimal places. I made the several decimal places appear on my calculator. If you don't have all those decimal places, go back to page number 2 or 3 where I do the setup and set up your calculator, okay, to have that display. Okay, now I ask a question. Can you solve this analytically without your financial calculator? So algebraically, this is probably what you did in 3106, unless you were with me, is you solved it mathematically. So you take 1,000 divided by 900 is equal to 1 plus I squared. You do the opposite action. I'm going to cancel these. Oh, and I'm going to minus 1. So you could do this mathematically, analytically, solving, isolating I. Oh. So it's 10 divided by 9 equals square root. I'm just showing you if you're not used to this calculator. And then minus 1, and you see it's the same answer. Now remember, the arithmetic keys on the calculator will give you the interest as a decimal, but the time value of money row number 3, gives interest as a percent number. Okay, it represents it as a percent. Not 0.05, but 5.4. So that is the same answer. For the test, I want to be able to see on your homework, or test, I guess they're tests, I want to see this formula for points. This will give you no points. However, some students like to write it out, okay, for themselves. I think it's fine. That way they can remember what they did when they review for the final test. They can read their own work. Okay. So I want to see that and the final answer. Really, that's all I need to see. I need to see the formula with the numbers inside. You will not get points for just the formula. Okay. All right, the last variable. So now I give you FV, PV, and I give you I, and you have to find the exponent, the number of years or periods, or in other words, the duration of the investment. So here we have, how long does it take an investment of 1,000 to become 10,000 if the rate of return is 8% per year? So I write up the expression again. 1,000 accumulates, this is my factor, this is my t. Remembering that this amount is a negative, for that's what you're investing, and this is a positive because that's what you're getting. So this is all, again, it's easy. You just have to get your signs right. Going into your calculator, you'll find the answer is 29.92. So I'll put that in the calculator, and then we'll answer the analytical question again. And then I'll tell you, I'll clarify what I expect to see on a test again. So a clear TVM, second clear TVM. T is what I want, so N is empty. 8%. PV is 1,000 negative investment. No payments to earn 10,000 future value return. And then asked to compute periods. And that's it, 29.92 years. All right, you could multiply 0.9188, like the decimal, by 365 days to find out how many days that is. Okay. All right, so how would you solve this analytically? How can you solve for t? You guys, let's see this together. Well, I take this expression and I isolate for t now. I don't know what that noise is. Let me put the sound off for a second. I have no idea what that noise is. I have to go check it out after. So let's cancel those. So then it's t equals 1.08t, and I take the log of both sides, and that brings that down. Now hopefully you remember logarithms. Hopefully this jogs your memory and you're following along. If not, let me know. So then we can find t is equal to log 10 divided by log 1.8. And you'll see this in your calculator. I'll punch it in. So on this calculator, you have to put the log, no, you have to put the number first. Okay. So log 10, so 10 log divided by 1.08 log. Yeah, that works. And we get the same answer. Calculator is a little bit low. I'll put it up a bit. Okay. So when do I want to see this, and when do I want to see this? Well, I always want to see this part. I always want to see this, and I want to see your final answer in the units of the question, because the question says how many years will it take. But if I ask you to show your work, you have to do this. The same thing with this problem that we did. This is also in response to show your work. That's what I'll say. Okay, so I don't expect this well, on the test I'll say at the very top in the instructions, show your work. But in each problem, I would like you to, if I say solve analytically or solve algebraically or something like that, I want to see this calculation, okay? You should be able to do both. You should be able to manually solve this. Well, obviously this is not manual because you're going to put it in a calculator, but I mean isolate I before solving for it. And use your financial calculator. Okay, you should be able to do both. The Excel would be something else that you might not know, and I'll review that briefly. That would replace this finance calculator. The thing is, you can't use Excel on your CFA exam if you write it, so I'm concentrating on the calculators for that reason. All right. So that's it. That's the time value of money relationship. We can talk about accumulation. We can talk about discounting. Where I have again mentioned the variables. Keep in mind, all of these problems were solved imagining that the cash flows are at the end of the period, which is an assumption because it's not necessarily the case, right? People make payments, receive, well, the stories I told, it's the case, but you can use these formulas. If you use them, you're making that assumption that the payments made and the amounts received are at the end of the period. Another example with log. I don't like making up questions just because we have so many to go through. Okay, so let's just make up a question with log. I don't know. I'm gonna get, every time I make up questions, like, I don't want to waste any time. Okay, let's see. 203 to the power of 6 equals 5x. Solve for x. Why did I do that? No, the x has to be the exponent. Look how funny. See what I mean? What am I thinking? Back to this. Alright, do that again. 203x equals 50. So when I want to isolate a variable, I have to do the opposite action. The opposite or the inverse action. So the inverse action of exponents is logarithm. Okay, so log both sides. Now the tip is that when I take the logarithm, the exponent is neutralized. Okay, the opposite action, just like if, for example, if so, like the x squared and the square root function are inverse functions. So now the variable is here, not in the top, right? But I'm just trying to make a point. If I use them together, if I do x squared and then I square root it, what does it do? it neutralizes, right? It gets rid of that exponent. While when the exponent is the variable, then logarithm is the inverse function, and it neutralizes the power. So it goes down. I don't know. That's the way I think about it. And then, so now all I'm doing is isolating x. Now it's just related to this amount by multiplication. So I do the inverse function, which is division. And so I divide both sides by log 203. And put it in the calculator. Say again, 50. So clear. 50 log divided by 203 log. So you always have to write the number first, equals, in this calculator. If you have a different calculator, you don't have to do that. Is that all right? What was my answer? 0.5097, let's say. So you can check your answer. You can take 203 to the power of 0.5097 and you should get 15. So I'm doing this because someone asked me to do another problem and I thought it could help. Okay, the main thing is understanding logs and exponents are inverse function. Logs and exponents are inverse function, so it neutralizes the exponent. Okay. Uh-oh, I left. Okay, hold on. So we did this, and this is the overview here. And then I get into net present value. So what I'm going to say about Excel is just have you play with it, because I'm not, that's something you can do on your own, but I'm going to tell you the key functions you need to work with finance, if you don't know. So to work with Excel, which I assume most of you know, but just for a level playing field, you use an equal sign in Excel, in the cell of Excel, to activate the functions. And then you should know which function you're entering. And you can find Excel functions for finance. You can search that online and you can get a list of all the different functions. So you'll see it goes by the variable names. So FV, oh, it's not going to be nice, is it? Let's see. So if I use FV and then I use a bracket, it's not showing me. In your computer, when you open Excel, it'll show you the variables that you need to enter. Let's see if they're showing me anywhere. Oh, why isn't it showing me? Very confused. I think I'd have to show you my computer. I didn't try this out first. I'm using my iPad Excel and it's different. Let's do it that way. So this looks different than what you're going to see, so I don't know how helpful it will be. But if I double click on the FX key, I get the finance functions, and if I hit FV, now it tells me, you can see that, which variables it wants. So I need to know which one I'm going to put there, and it asks, as you see, about rate, and let me open this up a little. Let me start over. All right, let's do it like that. I don't know where my keyboard went. Okay, I'm gonna hit that instead. All right, so if I hit FX, the functions come out. I hit financial, and then I have to scroll. This is different. So FV, if I want the future value, I get to enter the rate, the number of periods, payment, PV, and type. So let's go one at a time. Let's do the 8% problem. So I would put, okay, I'll do it there, 8, and then the number of periods, it's always 2 for our problems. We had no payment, so it was 0. And then PV, let's do the first one, because we're getting FV, right? So PV was 1,000. And to find out what the future value is. And then the type of problem, it's end of period, you have to tell it, and that's a 0. It'll tell me, oh my goodness, it's better on your computer if you don't know what you're doing. So entering that, what's the answer to that? That's $1,166.40, remember? Let's see if I did it right. Nope, I did something wrong. What did I do wrong again? I did not put the negative in, so this is very finicky. So what I'm going to do, because I don't want to waste too much time, well, I'm calling it waste time. I don't want to spend too much time on this, but I just wanted to show you I don't know how to get the negatives. I can't get a negative. I'm sorry, it's my iPad keyboard. Oh, let's use this one. Oh, no, it went away. So yeah, I'm not going to be able to demonstrate with this too many problems. Let's try. I keep on making the same mistake. All right, let's see what happens if I use this keyboard. Yeah, my niece warned me about this Excel in iPad. All right, so it's an investment of 1,000. What does it become? You have to put a negative there to get the right answer. And what am I doing wrong? Oh, I know what I'm doing wrong. Again, so in Excel, you have to put it in decimals, not in. All right, so it's good I made mistakes, so you see where you get stuck, but it's confusing for people who are already confused. So that'll give me an answer. So this is Excel. What I'll do is, I mean, you can find it yourself if you search Excel finance problems online. But I'll send you a sheet that I found that was pretty good. It's kind of long. It kind of it says more than it needs to say, but it's clear in the end. So that's the future value problem. The other functions that are there include you have PV for finding the present value, you have a rate to find the interest rate, and you have a number of periods to find the number of periods. So you guys watch me destroy that example. So let's see, so that would be, so anyway, that's what I'll say. So I'll send you, or I'll post, let me make a note to myself so I don't forget. Is there anything else that I said I would give you that I didn't share yet? I want to make sure I don't miss anything. All right, so how many of you have used Excel for finance? Oh, you can tell me in the chat. Payment is negative. We don't have any payments in these problems, Jacob. Okay, so Naisabeth, she's used Excel. So that's good. So now I'll send you guys a link to some instructions so you can just, at least if you ever have to use it, you know where to go. Okay, so I don't need to teach you, some of you know already, but the others, it's not a priority for me to teach Excel. But since we're operating by distance, some students might see that it's handy. In the regular courses where we meet, I won't let you use Excel on a test, so there's no point to focus on it. All right. Okay, so that brings us to net present value. That's also in Excel. What's net present value? You should have learned this as well. And I'm going to give you an example with a simple case and ask you some questions. If you believe that, you believe that if you buy a hotel for $3 million today, you can sell it in 5 years for $4 million. You identify an interest rate of 8%. So you're going to use an interest rate of 8% because you think if you don't buy this hotel, you're going to, instead of operating in the property or real estate market, you're going to move to the financial markets, and you will look for an interest rate of 8%. That's what you're prepared to loan your money at. Okay, so that's why we're using 8%. There's many interest rates out there, but that's the one that we're focusing on here. So should you buy the hotel now? It looks good, right? I'm going to make $1 million. However, let's be more precise about whether that's worth it. Let me make sure you can see this. Okay. So let's see. How could I do this analysis? One way to do this analysis, this is a financial analysis, is to say, well, what if I didn't buy? So this is the buy option here. But what if I didn't buy? If you don't buy, what's the other thing I mentioned you would do? You'd go to the financial markets with the money, right? And what would you make? Well, there are 5 periods. So I learned that the future value in 5 periods of $3 million should accumulate to 1.08 to 5. So you can use the time value of money keys to get your answer. So let's put that in. So 5 periods at 8%. Remember, for the calculator you use whole numbers or percentage numbers. The PV is going to be 3 million. So 1, 2, 3, 4, 5, 6. It's an investment and there are no payments. That is a 0. And then I can compute the future value. So there it is, 4,407,984.23. So that becomes 407. I gotta go back. 4,407,984. So which one is better? Clearly, this is better, right? Do not buy. So that's one way to find the answer to the question. You shouldn't buy because you make more if you invested the 3 million to get 8% because that's your prevailing interest rate. Now, even though this will give me the answer, this is not the way that we look at things in finance. What we do instead is convert future cash flows into today's dollars, so they can be comparable today, so we can compare them to other purchases, so we can understand what it's worth, the purchasing power of doing so. So what we're going to do instead is calculate the present value of this investment, but we're going to do it in net, meaning we're going to look at the cash outflows against the inflows. So we're going to get the net amount. And we do that by saying, well, the 4 million today is worth this. I have to discount it 5 periods. That's from the time value of money that we just learned now. And then to get the net, I'm going to offset that by the investment of $3 million. Now this will give me the same ultimate answer that I shouldn't buy, but this is the way we present our argument in finance, okay? So we will have, in a test situation, I expect you to write this out, net present value, you show me so this CF means cash flow now, so this is like the initial investment, call it initial investment. Or initial outlay. And this is the present value of future cash flows. So that's the formula I want to see, and then just your answer. Now, how do we do this in the finance calculator? These are all the details of how you enter that into your finance calculator. If you have the TI BA2+. I've expanded the formula here because it explains what we're doing here. The calculator, if you use it this way, and I'll show you another way, but if you use it this way, using the CF cash flow keys, you need to give a place mark. Even though there's nothing happening in those periods, you need to tell the calculator nothing is happening. All right, so I expand the formula. In a test situation, you don't have to write all this, but I'm just showing you, demonstrating what is this that's happening here. So in the CF keys, you begin by pressing the CF key to open the worksheet, and then begin to enter your amount. So let's do that together, and you have it in front of you so you can follow. I'm going to hit CF, and you see there's nothing there. So I'm going to tell the calculator the initial investment by entering 3 million. Enter, and then I hit enter, and then I scroll down the worksheet. So I go down below and I put in the next cash flow. The next cash flow is nothing happens, right? So it's going to be 0, enter, and then arrow down. Now what's this? F stands for frequency. Well, how many zeros are there? There's actually 1, 2, 3, 4 zeros. Couldn't I just use that F? Couldn't I just put the frequency as 4? Yes, I can. So I can enter that as 4 zeros, and scroll down. And even though it says cash flow 2, I've told the calculator that I had the initial investment, 4 periods of nothing happening, and then the final period I'm going to make $4 million. So $4 million with a positive, and I enter it and scroll down, and that's a frequency of 1, and I'm done. So what I just did is different than what you have on the page. You can do it the long way, or you can do it this way. I'm just showing you what F means. Okay? So the key is to put the number, enter, and scroll down the page, the worksheet. When I'm done, then I ask to compute NPV, and the calculator asks me for the interest rate. We know the interest rate is 8%, so I enter, scroll down, and now it tells me NPV of 0. That's not correct. I have to recompute NPV to get the answer. So it shows me the NPV is a negative, which tells me what? Does anybody know what negative means? Negative 277,667.21. If you want to know about the TA84, you need to email me, Nicebeth. It's very different, and I'll waste time on that otherwise with the other students. So I can send you the slides, and you'll have that. I send them to someone, I'll send them to you, I'll forward them to you. I just emailed them to you, so you can look at those. All right, was that confusing? Was that okay? So you could do it the long way, entering 0, 0, 0, 0, or just jump through and make the frequency But I recommend nice bet, don't do it right now, because then you're gonna miss the class. Okay, so I asked you the question, what does this mean? The rule is what's called a net present value rule, is invest if the net present value is a positive, so it's profitable opportunity. Otherwise, and it's a profitable opportunity, you've offset the future cash flows in net present value terms by the initial investment, and you found out that it is, in this case, a negative. So it tells you do not invest. Right. Okay, very good. All right, so I'm going to modify the hotel example. Does anybody have questions about the calculation? NPV also can be solved in Excel. Now you need to know your algebra, because sometimes I'm going to ask you for different, well, maybe not exactly in an NPV, but you should know algebra enough to work with problem solving for different variables, and that has to do with any kind of problem. All right, so you guys are good with this. So let's see, what if we modify the problem to see if the investment will be worth it? What if we don't plan on just sitting on the property and not doing anything with it? Let's rent it. We have a property, we have an asset we can rent and earn revenue. We're going to buy the hotel for $3 million and sell it in 5 years for $4 million. That's the market value in 5 years. We anticipate. I mean, it's just a guess. Like, we don't know for sure, but that's what we believe to be true. And based on that, we make our calculations. In the meantime, you can earn rental income of $200,000. We estimate. In the third and fourth year. Again, we're going to stick with the 8% interest. Should you now buy the hotel, we'll do those amounts of $400,000 in the future offset that loss, that opportunity cost. If this is picking up, it's comparing it. It's doing the comparison that we did here of losing out on the opportunity of investing in financial markets. That's what it's actually picking up. So it was negative 277. Is this enough to offset that negative 277? Let's see. So now we have this expression. Again, I've written it to show you that you would have to put 0 into your CF keys if you do it the long way. So let me give you a moment. Let me know when you're done. Let me give you a moment to try and enter that. Do it both ways, using just putting 1 into the frequency key and another where you're using a 2, right? These are 2 here. Your frequency would be 2 zeros, and then here this would be 2 as well. Diego, I don't know about what you entered in Excel, but I'm sure this is the right answer. You must have entered something incorrectly. So I'm going to do this using the frequency approach. I'm going to stick with what I have in here. Let's see if I can just correct my value. So I'm going to scroll down through the worksheet. So CF0 is negative 3 million. And then there are 2 zeros, right? So it's going to be the cash flow for year 1 and 2 will be 0. So I'm going to change the 4 to 2. So that's 2 periods. And then I have to fix this. So then the next thing that's going to happen is I'm going to earn $200,000 for 2 periods. So enter, down, to enter, down. And then I'm going to get $4 million market value if I sell it. So enter, down, and one of those. And now I ask to compute NPV, the interest is there, and again, down, I have to go down and recompute, and that, why do I have that number? Yes, 28,000. So again, if you want the notes for the TI 84, 83, you have to email me for those. Jose, I can forward them to you as well. I just forward them to another student. Okay, I'm going to forward. I don't know if you get that. Have the experience where Outlook freezes on me. I have to open it again. Uh-oh, I lost connectivity. Hold on. You see? Yeah. So this is not a pretty thing to put into your TI 83, but once you learn it, you get the hang of it. Let's see, it was Jose. I'm going to forward that to Jose Bernier. Let me know if you did not get it. Okay, let's continue. So now that's a positive, so we should invest. So we should invest if we actually do something with the property to create revenue, to generate income from this asset. Okay, so any questions about the net present value? Okay, no questions, comments. All right, now we're gonna use the same technique on our calculator to solve a different kind of a problem. In the previous problem, the cash flows were level. They were the same amount, and that pattern was useful. Oh, you guys didn't hear me. I don't know. I don't remember turning that off, but okay. The sound was off. I hope you have no questions. All right. I guess we took a little bit of a break. All right, so what if, no one's asked me any questions, you're good with this. If not, you're gonna try it later, okay? Let me know, don't be shy. So what if your timeline looks like this? This is known as mixed cash flows. We're gonna use the same worksheet, the cash flow worksheet on your financial calculator or NPV in Excel if you're using that. But now there's no pattern recognizable as it was here or over here. We have mixed cash flows. So how can we use the NPV or the cash flow worksheet to solve this problem? Not only are the cash flows mixed, the other issue is that I'm looking for something slightly different. What I was looking for here was the present value of future cash flows and offsetting the investment cash flow with the revenues. So the expenditure against the revenues in the future. In this case, I'm I'm noticing these are all positive. So what's happening, in fact, is I want to know what it's worth to me to get those revenues in the future. What is it worth to me to get those revenues in the future? What would I be willing to pay for such an investment? So this is what it looks like. So I've just reapplied the time value of money formula over time and say this would calculate to be the present value of future cash flows. What should I invest today to make that fair? In other words, what's the most I'd be willing to pay? What is the most an investor should be willing to pay for that? So I'm going to say, so just to break even. So when I look at that, I've written up this problem as an equation, and now what I want to do is convert it so that I can actually use the NPV worksheet on the calculator with the CF keys. So I invert these, and now what does this tell me? For the initial investment, I should put 0, put the string of revenues for the next 5 years, one at a time, and then what I get represents the NPV for my answer, but it is the fair price or the market value of the initial investment. So that's how we're going to interpret it. Uh-oh. Okay, so let's enter this into the calculator just like we did before, and you get this answer. So let me give you a moment to do that. questions? Very good, Jose. Are you using the notes already? No comments? Comments? All right. So remembering how to use NPV in this special case, you have to put 0 first. That's the main thing you need to remember. That you put 0 for mixed cash flows. So the initial cash flow. And then the result you get represents your investment. So the NPV will come positive, which represents the negative of your cash flow. Anyway, basically just remember if it's mixed cash flows, you use 0 first, okay? Good, nice breath. All right, so this is in conclusion. I noticed some students have left. I hope they watch this video just to make sure they know what they're doing. So for a finite number of mixed cash flow, these are keywords, this is your formula for net present value. So I've allowed the cash flows to be different for T periods. If there is a pattern, things can be simplified. Now, if there was a pattern, like there was a pattern for the hotel purchase, and we use this CF and PV set of keys, and it was kind of lengthy to enter that, but we found a shortcut. Well, what if there's even a stronger pattern? What if cash flows are infinite? Are we going to sit at a table, a desk, and keep entering cash flows into our CF keys to find the NPV? Well, that's not practical. We need a better way. Before I go there, is it possible that cash flows are infinite? What example can you provide me that where cash flows are infinite? Is that even a practical interpretation? In what setting or what sort of problem or valuation would cash flows be infinite? Juan, you got the wrong answer. What were you using? Okay, so my question was, in what setting, when are cash flows infinite? How is that even practical? What does that mean? Okay, when is it going to be in perpetuity? No, Jose, there's not going to be an in-person class. Do you need an in-person class, Jose? If you want to meet with me, we can meet. Okay, so the question was, in what setting are cash flows infinite? I guess you aren't sure what I'm asking. So for example, if you own stock in a company, a person who owns stock in a company, that's a corporation. A corporation could potentially exist forever. So we make the assumption that if you're a stockholder, that share can earn revenues through dividends indefinitely, so forever. So that's an example. I'm not sure what just happened. Anyway, stock valuation. To figure out the value of stock, you would think about the revenues that accrue to having a share in a company, and you would think about it as forever. Now, you might not live forever, but that share could be traded and it could continue to earn revenue. Or you could, if you own the share, you could pass it on to your children or some beneficiary, and it could potentially exist forever if the firm existed forever. Right, Felix and Jose. Okay. And there's other examples, and I'll talk about those. So what if the cash flows are infinite, or what if the cash flows are the same? Are there simplifying formulas? Because why would we retype the same numbers again and again into our Excel or into our calculator? In the case of the calculator with level cash flows, I guess we could do that using the frequency key. But is there another formula that we can create since there's a pattern? So here's an example of a bond that pays indefinitely. It's known as the British Consul bond, and the British Consul bond pays $100 per year forever. This one, anyway. So you're told, given a yield to maturity of 5%, what is the fair price? In general, the formula that I've taught you, the basic time value of money formula, we're going to adapt it now. Okay, we're going to create new formulas from that basic formula, because now we have payments. So I'm looking at payments over time, and I'm not going to use the NPV approach. I'm going to derive a formula to solve this that is a simplification of what we've been doing. Okay, simplification. So what would that formula be if this is the time, this is the timeline, and this goes on forever? So we think about $100 is received every year forever. And where does that come from? I'm going to use a different color. It comes from depositing an amount PV and earning 5% on the deposited amount. Correct? So it's like having a fund that just stays constant. I mean, I don't draw from the fund. All I do is receive the interest on the deposited amount. So you can think of it like that. Yield to maturity is the equivalent of the interest rate or the opportunity cost that we're going to use for this investment. So if I actually purchase the console bond, essentially I'm loaning money to the government, right? This is a government bond. And I'm loaning money, and they promise me $100 forever. So they have a fund, and it pays 5% to make 100. Well, couldn't I simply solve that and get and this tells me the value. I can find the present value of that investment by doing that. So that's just an example to get the answer, but it does give us the perpetuity formula. So you get $2,000. So this gives us, this helps us understand the general formula for perpetuity is going to be the payment that's received in the first period that continues forever over the discount rate, or the yield to maturity we call it for a bond. Now, this is the formula provided certain conditions apply. Let's work through those conditions so we keep in mind, and this is on your formula sheet with the timeline, but let's work through what the conditions are to actually use this formula. First, the first cash flow one period away from where you want the valuation. I'm going to say 1 period from now. Or I'm going to say in 1 period. First cash flow in 1 period. So it has to be that the first cash flow is 1 period away from today when you're valuing the asset, the bond. And what else? Cash flows are the same. And what else? And cash flows are infinite. So those are the conditions required for using this formula. So first cash flow in 1 period, cash flows are the same, and cash flows are infinite, okay? Otherwise, this formula doesn't apply. You can use it, but you need to adapt it to suit your problem. And so I've just repeated all that here. So just to say that the yield to maturity is like the interest rate for bonds. In simpler words. Okay. Okay, so we solve this one. So how does it work? How does an infinite amount of money become just $2,000? That's the thing I want to talk about right now. Infinite cash flows ends up with a value of $2,000 today. How is that possible? Well, it's possible because of the time value of money. If we look at each cash flow one at a time and discount them, notice that $100 in 1 year is really worth $95 today if we discount it to today's dollars or today's purchasing power. In 2 periods, the $100 that we got that we will get is only worth $90.70 today, again because of the time value of money. I can do this, repeat this for a while until you see these eventually, because they're decreasing in present value, eventually we'll just be adding amounts in the present value that are zero. So what we should be doing is discounting each of these and adding them. That would be the NPV, right? But at some point, we just be adding zeros. I don't know exactly when that would be, but eventually we're adding zeros, and that happens after we reach a present value of $2,000. So we don't do it this way. We don't use the NPV approach. We identify that there's a relationship. This is actually something you should have learned in high school about series functions or series of numbers, and that's where this formula derives. And I just use this argument to simplify the understanding. I mean, this is the simplest way to understand how to drive that formula. All right, so because I'm eventually adding zeros, the number does converge, the value does converge to a value, like a fixed number, and it will do that after it reaches $2,000 of value. All right, so this is the timeline. In general, it looks like this, C1, C1, and so you have that on your formula sheet. To remember that the first cash flow is one period from the day of valuation, the cash flows are level, and the cash flows are forever. All right, another example, you mentioned, and I mentioned, the case of stock. In valuing stock, a stockholder will think about the present value of future cash flows. And the future cash flows could be indefinite. They could accrue forever if you imagine or you assume the corporation exists forever. In this case, I'm going to add some more realism to this problem by thinking, well, it's anticipated, we're going to assume that the company will grow, and it plans to grow also indefinitely. It's going to grow at 2% a year. So that's going to, in terms of revenues, that's going to be paid out at 2% increase in dividends to stockholders. So imagine that stockholders, what do they get? The stockholder receives $100 per year, let's say, in dividends. But we're going to add to that by 2% each year starting in the second period. So $100 the first one period from now, and then the growth kicks in. So 2% and forever. So what are the conditions here? First we're gonna look at the formula, and then we'll go over the conditions. So we need to recognize there's a pattern here. If I use the NPV approach and I discount future cash flows, I can see the pattern I'm looking for. Cash flow will still diminish over time, however, at a slower rate because the cash flows are now growing. This growth rate offsets the time value of money effect, or the erosion of the dollar, as a result of time. So how will we work this fact, we're going to call it G. G for us is the 2%. I for us is 5%. All right, so have it clear that there are two rates here, but don't get confused. The interest rate that I call I is the rate of return, or the, what did we call it here, required rate of return of 5%. So stockholders consider a rate of return for their calculations. They'll use a rate of return that reflects what they're requiring. If they weren't investing in ABC, they would search for an investment that promises, or historically, or they anticipate will give them that 5%. So that's the one that they use. That's their prevailing interest rate, their rate of return. The G represents the growth of the cash flows. Okay, so Misael asked a good question. Let me finish this and then we're going to talk about that, okay? So modifying the formula. So you need to realize we have an extra rate here, and now how do we work that in? So this is the way we're going to work it in. We're going to say that the effect of growth dampens the erosion caused by time value of money, that $1 today is worth less in the future. Let me say that here just before, because I mean that is another way of saying everything I've said so far about the time value of money. So So which one would you pick, option 1 or option 2? So I'm repeating what I've said before about time value of money, but this is just another way to capture the concept. Would you prefer $1 today or $1 in the future? Option 1 or option 2? Right, of course, right? Because if I'm going to make the comparison here, or compare here, I have to compare in the same time period, right? Because I can't compare dollars across time periods. I have to compare them in the same time periods. It's like converting it. So I know $1 today is smaller, is greater than $1 next period, because it's only worth this. I have to discount it. That's a consequence of the time value of money. If I is 8%, then this is 1 over 1.08, and it's smaller than $1, right? So if you put that in your calculator, it's 93 cents. So comparing these two, option 1 is greater. So yeah, and it's also just simple, like why is that the case? Because you get the dollar now, you can do something with it now. Why would you wait? You can do something with it now, you could invest it now. If you invested it, that dollar in a year would become at 8%. Again, if you compared at time 1, now you're comparing $1.08 to 1. Again, you're always going to pick option 1, whether you're comparing at time 1 or comparing at time 0. All right, so delaying is not preferred to getting the money up front, because from the perspective of today, delaying makes the money worth less to you today. So what we're going to do then is offset that time value of money effect by the growth rate. So this makes this smaller on the bottom. Now this formula applies, it has conditions for applying. This is the annuity or perpetuity with growth formula, it's called. And what are the conditions? First cash flow in one period. So I say period or year? Yeah, just like that. So it's similar. First cash flow in one period. Cash flow the same. Cash flows are infinite. And what else? Growth starts in second period Remember, this is period 1, this is period 2. So growth starts after period 1 in period 2. And the growth never changes. It's always the same. All right, so those are the conditions for this formula. In addition, the formula only works if I is greater than G. Now, mathematically, you can see why that is. If I is greater than G, then that ensures this is a positive number, right? Because that would be greater than that one. And that ensures that the value of these future cash flows is positive. So mathematically, that's why it's the case. But what about, so if I was, what would happen if I was not greater than G? Can someone tell me? So imagine this case. I guess this is the best way to look at it. Here you see that I is less than G, and these are going down. But if I was greater than G, what would happen? They would increase, but what would be the answer to the present value? Sorry, I'm reading emails. So what's your answer? They would adding higher and higher numbers, so PV0 would be infinite, which just would not exist. Everybody would invest in this. And with what money? You'd have to have an infinite amount of money to invest in it. So it just doesn't make any sense. Okay, so it doesn't make any sense. The answer is infinite because you're adding higher and higher numbers. So it does not converge. I don't want to say that because there is an answer. The answer is infinite. All right, so they would blow up and you would have infinite. So we say that this formula only applies if I is greater than G. So let's try this problem finally. Any questions? Any questions? So notice this value is higher than the 2000, right? When there was no growth. Any comments or questions? This is higher because your cash flows are assumed to grow at 2% forever. All right, so if you don't have any comments, then I'm going to make a point that notice we didn't use the time value of money keys, we didn't use the worksheets. These were just formula, and these formula you should be familiar with. They're on your formula sheet. There are no special keys in the calculator to compute them. You just have to know the formula. In the case that the simplification formulas do not apply, then you need to use the mixed cash flow formula. So here is, no, this is an annuity. So somebody asked me, let's do two modifications. Let's do two modifications. accidentally moved out. So I'll say modifications. So $1 forever starting today, $100 forever. So the timeline so $100 forever starting today. Well, the thing is that I know if I remove this amount, I know the rest of it, right? I know the answer of the rest. That's the rest of it. It's $100 at 5%. That's the perpetuity for that. But then I just have to add in the $100. So this one was 2,000. So the answer is 2,100. How's that? What if do a different modification? What was the other one I wanted to do? Oh, we'll do that. It's in the notes, so I don't have to do that. So I'm going to say, I'm going to call this just like that, modifications. I'm only going to do one. I just had to add the extra 100 in. All right, so let's see. What if the cash flows are not infinite, they're finite? If the cash flows are finite, all that changes is that we don't pay or we don't receive payments indefinitely, okay? This is an example, it's a car loan. So car loan is a payment of $100 in this example for the next 4 years. In other words, it's 48 months. At an effective rate of interest of 1%, how much did you borrow for that? So how do we figure this out? Just like I showed you in the modification, I'm going to take advantage of the fact that I know this is the perpetuity formula. So this is, if it was a perpetuity, it would look like this. But to be an annuity, that is a finite set of level cash flows, it means that I won't pay these, which is another perpetuity. So I have a perpetuity here, and I'm going to subtract the perpetuity over here. These are the amount, the value of the cash flows I don't pay. So in general, I can derive a formula where I subtract this by this amount discounted. So what I'm going to do is take this perpetuity and discount it. So here's the discounting factor. So what I have to do is subtract this perpetuity by this discounted perpetuity. And what I find, so you could review this again on your own when you review the video. I'm going to use this technique many times where I take the present value of future cash flows of the perpetuity and I remove the amounts that I do not, in present value terms, that I do not have to pay in the future. So those are those two amounts. And what I have is the perpetuity with an adjustment to remove those payments I will not have to deal with. So this is called an annuity. It's a modification of the perpetuity formula, and it has conditions as well. So let's go back to the perpetuity and see. I'll copy and just modify the conditions that we had. So the perpetuity here, we had these conditions. I'll copy these over. I'll put them here. Okay, so these were the conditions for the perpetuity, but now the difference is the first cash flows in one period, the cash flows are the same, but they're not infinite, right? So still those rules apply. The first cash flows in one period and the cash flows are the same. So I'm going to use the symbol C1 because they're all the same. And I use the 1 subscript because that reminds me that it's one period from now, right? So that is an annuity. So here's a problem, and I'm going to show you how to put it into your calculator. So you obtain a loan to help you make monthly car payments of $100 for the next 4 years. The effective monthly interest rate is 1%. So in this case, the interest rate is the interest rate on the loan, and this is what you could get. Okay, so this is the interest rate that we're going to use. So maybe a credit rating agency determined, or the information from a credit bureau was used for the company loaning you the money to determine that you have a monthly interest rate of 1%. So that's what's available to you. So that is, here's the timeline. These are constant cash flows starting one period from now. I plop them into the formula. remember, this is the perpetuity with an adjustment, and this comes from the fact that off into the future, I'm not going to pay those payments forever, so I need to take it off. So this is the formula. What I want to do now is show you how to get this out of your financial calculator. So you're going to write on your test, you would show me this. You could write the timeline as well, but this is not so complex a problem that it's all right. You know, I like you to write the timeline, because if you get the answer wrong, I can look at your timeline and see your reasoning and give you some part marks if you have a good reason. I can give you all the marks if your interpretation is reasonable. Possibly I didn't write my question or problem clear enough, and your interpretation is acceptable, but I need to see your timeline to do that, to give you part marks or whole marks. All right, so let's enter this into the calculator. So back to the time value of money row now. We have these keys, and now we're going to start using the payment key. The payment key payments are cash outflows, so they get a negative. So let's work from left to right, 48 periods, because I need to, so this is an important point too. When you read these problems, you have to first identify the timing of payments. In this case, it's monthly. And then adjust or convert all your variables to monthly amounts. So you need the monthly rate, which was 1%, 48 months in the years, and then the amount every month is 100. So 48 periods, the interest is 1. We want to find the present value of that loan. The payments are $100. And notice we're not going to use FV now, so we put a 0 in there. Okay, we have payments. And then we ask to compute for the PV, and this is the answer we get. And that's all I need to see in a test situation. If I see something else, I might not give you any points. So some students have shown me things like this, I give them 0. Some students show me what they wrote in Excel, I will give them 0. I need to see the formula and the result. Now some of you who learned about annuities, you took 3106, you actually had to enter this into your calculator manually. You might have been able to do that comfortably with the TI 83 or 84. I want to look at how I would enter this into my calculator if I'm using the TI BA2 Plus. Why am I going to do that? Because I want to show you how to work with the annuity function in the instance that you're solving for a different variable. Anyway, things can get very complex. So next weekend, I know, we have the test next weekend, right? So yeah, we have this class and then next week's class. And then we're gonna have a test, I believe. I'm gonna double check that. It's next week. All right. So it's just like a review, essentially. We will get into, well, it'll be I have to make it challenging. So you have the review exercises that I shared with you that you can use. I'm going to send you some more today after class. All right, so let's see about entering this into our calculator manually. If I was to enter this into my calculator manually, I would start here. I always start in here. I start with my exponent. So I would say 1.01 y to the x 48 and then equals. And then I would use the 1 over x key to flip the amount and then change the sign. Then I will add the 1. So I'm working backwards. I'm going like this, I'm flipping, I'm putting the negative in and adding 1. So now I have this whole amount. Let me put the 1 here. So I add 1 and then I multiply by 100 and I divide by 0.01. So try that. The test is next week. It's in the syllabus. All right, so what if I'm going to do now a modification. So any questions about this, first of all, the annuity? Try to use your finance calculator and not just the TVM row, but use a finance calculator to calculate just to practice. So here's another modification of the problem. Let me just wrap this up and say the loan to be able to pay $100 for 48 months would be around $4,000. It's $3,797.40. And I can't believe I have to tell you this, but some students will actually tell me on the test that it's 100 times 0.01 times 48. But that is not the answer, right? That's a simple interest. It's wrong. So I will have no tolerance for wrong answers. I won't even really read it. I'll just mark it 0. What did I just do? I want to just do 100 times 48. Sorry. They ignore the interest, in other words. 100 times 48, or 48,800. That's not the answer. That was even giving them more credit, like they were looking for the interest. This is the value of that loan. Okay. So what if again, a modification. What if the first payment is now? So this is a situation where, so for instance, let's look at this problem here. In renting, you have to pay up front. So you would have to pay your rent, your rental payment, your fee at the beginning of a month. So here's an example. You sign a 5-year lease to rent your office space to a dentist. Okay, so you own the office space, you're going to rent it out, and they have to pay, the leasee has to pay $1,200 per month at the beginning of every month for 5 years, with an effective monthly interest rate of 1%. What is this deal worth to you today? How does that change things, that this is the first cash flow? Well, one thing is, well, it shifts all the cash flows back. So it's going to begin now and it's going to end on the 59th payment, or 59th year. This is actually the 60th payment. Let's be clear. So how can I calculate that with my annuity formula? Let's make an adjustment to the annuity formula. Same technique. Here's my perpetuity. If I leave this out, I'll just add it in later. You see, I have a box around it. So this is the perpetuity up till here for T payments. Sorry, up till, sorry. So this is my perpetuity here, but at this point, one less, right? Because the first one is here. There's the rest of the perpetuity. So I need to do the same thing as I did before. I don't pay these, so I'm going to subtract them from these amounts. So you don't have to repeat what I've done here. You just need to understand this is the basis for these formulas, where they come from. So I'm going to subtract this discounted perpetuity, this is the discounted perpetuity, from this perpetuity, and I'll leave this aside because that has to be added as well. So this is what you get. You get that C1, the upfront payment, and then you have this situation, which I demonstrate. This is just a perpetuity times an adjustment factor. The only difference from before, so these are the differences from the annuity in the formula. It's T minus, so it's an annuity with one less payment because the first one is here. So after all said and done, all that notation just falls down to this. So those are the adjustments here in the formula. So this is the annuity, this is known as the annuity due, or annuity upfront, or what else? Annuity in advance. So that was the adjustment, so you can do this. Now, let's look at this problem, and there's going to be 3 ways we can do this. And you can use whichever method you like, but all the techniques are useful to you to solve even more complex problems or different problems. I don't have a standard approach. So this formula is not on your formula sheet, so you should add it. If you use the NPV, you would just write this, where this is 59, right? This is the general formula here, and you should add this to your formula sheet and be clear how to use it. So I've just repeated it here. So how do we get this out of our calculator? We can do it the long way, entering starting here, working through it, and adding 1,200 not to forget. So let's work through the different methods. This is the first method. What I could do is say there are 59 annuity payments, and then I can't forget I have to add in the first one. So that's one way to do this. A regular annuity and then add in this to get the final answer. So it's 59, one interest, 1,200, so let's do that together. So you act like it's 59 in payments, interest of 1, PV is what I want, and the payments are 1,200. And I put a 0, I have to override whatever's in there with a 0 and ask to compute the present value. Now it comes as a negative, so I should change that sign. Or, I should have probably entered my payments as well, I do receive those. So anyway, make sure this is a positive before you add 1,200 to it to get the right answer. Any questions? Do you want to see that again? So don't forget to add this in. Before you add the 1,200, and you get the right answer. That's method 1. So 59 payments plus the first one. The other approach is to use begin mode in your calculator and just treat it like a regular annuity. So the only thing you're going to do to modify, the only adjustment you're going to make for this modified problem is that you are going to switch your calculator to begin mode. You hit second, begin, second, set. Now it's in begin mode. And then you enter as though you have 60 payments, because you really do, with an interest rate of 1 and a payment of 1,200. So let's try that. So what we have to do is turn our calculator on to begin mode. So second, begin, second, set. Now I see the BGN at the top of the screen. And then I enter values of 60 payments at 1%. The payments are 1,200 to be received. Put a 0 place mark in there and ask to compute. And I do get the right answer right away. So you might like that method, you can use that method. The trick is to remember that you have to turn that off. Before computing again, or computing something else. And the final method is to, you guys aren't saying anything, so I'm just continuing here. So you turn it off by doing the same, repeating the same actions. Second, begin, second, set. So that turns on begin, now turn it off. Second, begin, second, set. Now it turns it off. It just toggle to the same steps. Okay. Just do it again to turn it off. All right, the third method is recognizing that this timeline could be visualized as an annuity, but you would get if you treated it like a 60 payment annuity, a regular 60 payment annuity, what you would be finding is the value one period before. Remember, the annuity formula is for the first payment one period from today and the payments being level. So the value you find would actually be back here. Remember, this timeline goes all the way back and all the way forward. So what we would have to do to find the value here is use the annuity formula as usual, but then make the adjustment. And the adjustment would be to accumulate this amount one period to find the value here. Remember, time value of money. So I'm going to take and convert these cash flows as an annuity into one lump sum and then adjust that sum to be at time 0. So this is what it looks like. I want to adjust this sum by one factor of accumulation. So it's the regular annuity formula with the adjustment. This will give me the same answer. And this is what I believe is programmed into your calculator. So when you put on begin mode, it makes this adjustment using the regular annuity formula. This will give you the same answer. This I call method 3. So regular annuity will give you this amount, and then you have to multiply by 1.01 to get the same final answer. So these are 3 methods you can practice. One of these has to go on your exam paper, whether it's this version of the formula, you can put this on your formula sheet, or the other one I told you to put is fine with me, okay? Again, I'm not going to see what you punch in your calculator. I just want to see a formula and an answer. So it's either this way or this way. So I'm going to send you some exercises to practice these things with annuities. And what I want you to do is solve the exercise I give you. It's an annuities handout. Solve the annuities as annuities. Don't use NPV. You need to practice annuities. I think I did send you all those documents already, actually. So I want you to practice all the documents that you have. It is review, so you can work ahead on the bonds, but I will repeat this next class. Here are the bond problems. You can work on these, and actually you can probably finish the notes in practice for the test. All right? So you have, let's just see. So we will talk about all this next class, and we'll have covered all the material for the test. And then on the weekend, you'll have time to complete the test. I said I can give it on Friday evening, and then you'll have until, what is the deadline I gave you? Juan, are you still asking about the begin? You do the same steps, second begin, second set, same steps. So I said I'd give you till Sunday at 3 p.m. If you have a different calculator, Juan, you have to look at the notes I sent you. Did I send you notes? I don't know. Maybe I didn't send you notes. I don't know which calculator you're using. I don't remember. I'm sorry. But if you're using the TIBA2 Plus, that's how you return to the end mode. And it's very good that you're concerned because it's very important you have it in the right mode. So next class we'll talk about annuities with growth, which is the last formula on the formula sheet. But otherwise, you should know all the formulas on the formula sheet. You should do this review the exercises, and come with questions next week. But I'm going to start here, okay? I'll stop here and start here next class. I'm not here, but back at annuities, bonds. We will begin here next class. Okay? So the interesting thing about bonds, so bonds, again, that's where you loan a corporation or the government money, and they promise to pay you back the principal, and they may pay you back in coupons or payments throughout the duration of the loan. And the interesting thing in terms of the calculator is that we will finally use all the keys on the time value of money row at the same time. So I'm going to say bye for now and meet you back here next week at 9 a.m. Unless you have any questions. You can email me, you can text me if you want to talk. If you want to get together, let me know. And we can do problems together, or we can do them online remotely. I will also post some questions in Connect for your practice. Okay? They are not due. I'm not going to grade them. They're just more problems for you to work on. Good weekend. Thank you for attending. Bye.
Sorry, darling, I didn't leave yet. I was just giving my class, and I'm very confused by this student. I'll show you though. So I'm gonna go. So what are you doing? You're home, and you can come at 1:30, or is that is pushing it? Well, why don't you yeah, pick me up, and then we'll go here. There's a little cafe here. Yeah, we don't have to make it complicated, and I can show you the computer. And the very confusing, I don't know what's happening. I'm communicating with a girl because she's not communicating with me, and now she just communicated and said she never heard from me. It's surreal what's happening. I don't know. I think she's crazy. So 1:30, yeah. Actually, can we I'm trying to think. How much time do you have? Right. Yeah. Okay. Can you do another favor? It's just that we have to, because of everything is kind of colliding at the same time. I needed to bring Gabriel to pick up his car. So it's in Santurce. It's like 10 minutes. So we'll drive there, drop him off, and then we can go for coffee, and we'll come back this way and we'll have coffee here. Okay. Okay. So we can just hang out. He wants to talk to you about something too. Okay. Bye.